So today we're going to review the trig functions and their graphs. So first we're going to start off with the unit circle, as we usually do. Alright, we're going to make some coordinates at 0, 90, and so on. So 0, 90, 180, and 270. So just going to give those coordinates. Don't forget that the coordinates are cosine, comma, sine for all cases. So this is cosine, comma, sine. So this is the unit circle again, so the distance across from the center to the edge is 1. So if we were to consider doing sine first, we would get 0, then 1, then 0, then -1. Those are our values, and then we come back around to 0 again, which is 360. So this is for 0 degrees, 90 degrees, 180 degrees, and 270 degrees. Then we come back to 0, which is also 360 degrees, which is why the sine curve, which is y equals sine of x, has this appearance. There are 5 points to a sine curve. You have your starting point, which is at 0 degrees, so this is going to be 0 degrees, and it's going to end at 360 degrees, which is going to start and end at the same point, 0. It's then going to rise up to its maximum point, which occurs at 1, which is at 90 degrees. It's then going to return to 0. So this is just following it around the graph. That's 0. So at 180 degrees, hold on, let me make sure I go in order just to avoid any confusion. So we're going to start at 0, which is our first point. Then we're going to travel up to 90 degrees, which is 1. So that's where the graph is going. So this is 1. Then we're going to travel back down to 0 degrees, to 0 at 180 degrees. Then we're going to travel to -1 at 270 degrees. So this is -1. And then the graph will return to 0 degrees, or 360 degrees, which is a full cycle. It'll return to 0. This section in the middle is called the midline. The distance from the middle to the top is called the amplitude. Where the graph finishes is called the period, and the number of times the graph completes the cycle in 360 degrees or in a period is the frequency. We'll get into more of the specifics in a moment. So that's where the sine curve comes from. So there should be 5 key points on your sine curve. It starts at the midline. It reaches its maximum, returns to the midline, its minimum, and then returns to the midline again. And that sequence starts by going up when the amplitude is positive. So if you have a positive amplitude, the graph will start going up. If it's negative, it will start going down. Now, unlike that, the cosine curve starts at 1 at 0. For 0 degrees, it starts at 1. So 1, -1, 0. This is going to be our cosine curve. We're going to start at 1. We're then going to travel to 90 degrees, where we will return to 0. So this is 90 degrees. Then we are going to return to -1. So we're now so we go from 1 to 0 to -1, which is our minimum, which occurs at 180 degrees. This is for the standard cosine curve. Then we will be returning to 0, which occurs at 270 degrees as we go around the circle. So this is at 270. And then finally, the graph will return to 1, which it will do at 360 degrees. So the difference between the cosine curve and the sine curve is that the sine curve starts at the midline. So the sine curve starts at the midline and goes up, unless it's negative. The cosine curve starts at the maximum and goes down, unless it's negative, in which case it'll start at the minimum and go up. So this is for when a is positive. Now we're going to take a quick look at the hold on. We're going to take a look at the tangent curve as well while we're doing this assignment. So the tangent curve comes from So tan y equals tan of x. Let me use purple for this. It'll be a combination of sine and cosine. So y equals tangent of x is going to come from, so tangent, as we saw in our previous class, is going to be sine over cosine. So if we were to look at the graph for the tangent curve, 1 and 0, and just divide the points. So 0 divided by 1, sine divided by cosine, is actually 0. So at 0, we get 0. So that's for 0 degrees. And for 90 degrees, we get 1 divided by 0, which is undefined. So at 90 degrees, this graph is undefined. At 45 degrees, which is not on this graph, it will be a radical 2 over 2 divided by radical 2 over 2, which is going to be 1. So 1 occurs at 45 degrees. To get an idea where the graph is going. So the graph is actually going up, and it eventually reaches infinity. So this is where the graph actually ends. So to get the rest of the curve, we're actually going to go backwards to negative 45 degrees, which reaches negative 1, and then at negative 90 degrees, the graph reaches, is undefined again. So that occurs down here where we have negative 1 divided by 0, which is undefined. So the period of the sine and cosine curves are 2 pi. So this is a period of 2 pi. This is a period of 2 pi. That's how long it takes to complete the full cycle. Now the cycles repeat because we just start going around the circle again. So if we go around the circle again, the sine curve will just repeat its steps. It'll just continue to do this. If the cosine curve were to continue to go around the circle, it will repeat its process as well. The tangent curve will also, it just does it faster. So if we look at the tangent curve, it starts at undefined at 0 to negative 1, then it increases to 0, then it will increase to infinity. So it starts at negative infinity and increases to infinity. Then as it continues to go around the circle, it will decrease. It'll start at negative infinity, increase to 0, and then increase to positive infinity. So it's the same cycle over and over again, but it does it in half the circle. So that's the 3 different circles. So important to note that the period is different for each of the graphs. So we're going to do a couple different graphs here. I'm going to start off with the tangent curve just to do something a little different. So first we want to identify the midline. So the midline is the line that runs through the middle of the graph. Now you need to kind of know where the 5 points of the graph are in order to do this. So I'm just going to mark them all. So we have our asymptotes. So there are 2 asymptotes. Then there's a middlemost point and the 2 points in between those. So these are pi over 2 is 90 degrees in this case. Negative pi over 2 is negative 90 degrees. So this is the period of this graph. The period of this graph is the distance between the 2 asymptotes, which in this case is 180 degrees, or pi. So that's the period. The other relevant points is the middlemost point, which will be our midline. And then halfway between 0 and 90 is going to be, so this is 0. So halfway between 0 and 90, we're going to have 45 and negative 45, which are going to be at 1 and negative 1, unless the amplitude is changed. If this value was 4, then the amplitude would be 4. Now technically tangent doesn't have an amplitude because the amplitude usually determines the midline to the maximum, but this really determines the midline to the middle value between the asymptote and the middle of the graph. So in this case our amplitude is 1, our midline is 0, the period of the graph is 180 degrees, and the frequency formula, which was included up here, says 2 pi over period. It's different for tangent. So for tangent, it's going to be pi over period. But that's just because for the tangent curve, the period is actually pi. So the period is different. So to find the frequency, we're going to do b equals the pi divided by the the period, which is 180 degrees, which is equal to pi radians, so pi divided by pi, so b equals 1. So this equation is y equals 1 tangent of 1x. So that is this graph. Now I'm going to pick two other examples to do. I'm going to do one sine curve and one cosine curve. I'm going to do number 2. So number 2 is a cosine curve, and I can tell because it starts at the maximum and ends at the minimum. That also tells me that this is a positive amplitude because the maximum, the maximum goes down when a is positive, right? So the amplitude is the distance from the midline to the maximum. So that's 3 in this case, and it's positive. The midline is 0 in this case. The period is how long it takes to complete the full graph. So the full graph starts at the maximum, ends at the maximum. So it ends at 2 pi over 3. And the frequency, which is the b value, is going to be equal to 2 pi divided by the period. So the period is 2 pi over 3, according to the formula we have from earlier. Now again, the difference between using the formula start with pi, as we did in number 3, and using 2 pi, as we are in number 2, has to do with the tangent curve just as a different period. So we're going to put this over 1 to use keep, change, flip. So we're going to get 2 pi over 1, that's the numerator, times the denominator reciprocated, so that's 3 over 2 pi. The 2 pi's will cancel out, giving us a 3. So that is our frequency. So if we were to write the equation of this graph, it would be y equals positive 3 cosine of 3x. Now the frequency is also how many times the curve is completed in 360 degrees. For a cosine curve, it'd be in 180 degrees for a tangent curve. But if we look at this closely, you can see it completes one full curve, then 2 full curves, then 3 full curves at 2 pi. So that's why the frequency is 3. It's better to probably use the formula for it. All right, so this is a cosine curve whose midline is 0 and has a positive amplitude. So let's take a look at a very different example. So we're going to take a look at a sine curve that starts, looking for a sine curve here. We'll do problem number 8. Now on the worksheet, I think actually we won't do problem 8, we'll do problem 5. All right, so looking at this example more closely, we can see that this is a sine curve because it starts at the middle and ends at the middle. We actually only see one full curve here, which doesn't mean the frequency is 1 because 2 pi is somewhere around 6. So the b value is not going to be 1, otherwise it would end here, but it doesn't. So the midline is 200, so the midline is going to be y equals 200. The amplitude is the distance from the middle to the top, so that's a distance of 500 minus 200, or 300. Now the sine curve is going up, which means the amplitude is positive. The period in this case is 16, so using the period formula for sine and cosine, that's going to be b equals 2 pi divided by 16. 16 being the period. So the b value is going to equal pi over 8 when simplified. So this equation is going to be y equals, the amplitude was 300, sine of pi over 8 plus 200 for our midline. All right, try the rest of the examples on your own. If you have any questions, let me know.